Hello, everybody, and welcome to a lesson in contemporary mathematics for 7A, section 7A, an introduction to probability. And you might be wondering, why is probability even a thing? Well, it's used pretty much everywhere. It's used in education, it's used in sports, it's used in what else? Gambling. It's used in the lottery, if you want to consider that under the gambling. Flight schedules. It's used in all sorts of different things. So it would be very good for you to be out there in the real world understanding how probabilities work. One other thing, just very quick, it's used in insurances very, very highly. And if that's something you're really interested in, go check out the actuary business. There's a lot of very interesting math that goes on in the background with calculating premiums and such. Anyway, so the basics of probability are just going to be demonstrated through many, many, many examples. So just for example, we have this spinner to the right, and all of these sections take up 1/4 of this circle. So 1, 2, 3, and 4 all are 1/4 of the circle. So if we ask this question, what is the probability of spinning a 4? You give this thing a flick, and it has one possible outcome with which we are happy over 4 possible outcomes. So that is how we go about finding a probability. We want what we want in the top and how many times that happens over how many possibilities are there. 1 out of 4. And very quickly, this is also equal to 0.25, and this is also equal to 25% from previous lessons. So just be ready to give your probabilities in any format, either fraction or decimal or percentages. Okay, so what is the probability of spinning an even number? Well, we have 2 possible outcomes for that, so we will have 2 out of 4 possible outcomes. The other 2 are not even numbers. So 2 out of 4 simplifies to 1/2, which is again 0.5, which is equal to 50%. So, okay, there we go. And again, you just have to be flexible, but it can't be 2/4. It has to be the simplified fraction. All right, what is the probability of spinning a 5? Well, as you look at this spinner over here, 1, 2, 3, and 4 are the only choices we have. So there are no 5s. We have a 0 probability of getting a 5. And the probability of spinning a number that is less than 5, I'm going to do that in blue, is, let's see, 1 is less than 5, 2, 3, and 4. They're all less than 5, so we have 4 outcomes that fit this scenario, less than 5. Out of 4 possible outcomes, well, that's 1. So we would say this has a probability of 1, or it's 100% chance that it happens. So, I mean, that's it. So now some vocabulary to actually hopefully get this probability stuff working out a little bit better. It says that we can use the following words to fill in the blanks. A choice may be used more than once. So, number 2, in probability, spinning the wheel, like we were doing up here, is referred to as an experiment. And that we can also end up calling a trial. But yeah, anyway, in probability, the action of spinning a 4 or rolling a 1, if you have a die or flipping a head, is referred to as an event. And those would have been the specific things up here in these examples, like even number, that would have been the event. A 5, that would have been the event. Less than 5, that would have been the event we were looking for. The number of outcomes for that particular event. In the example above, 1, 2, and 3, and 4 are referred to as outcomes. I don't think that's going to be any bit of a surprise with the wording I was using up there. An experiment is any occurrence for which the outcome is uncertain. In a probability, an event is a subset of the outcomes of an experiment. And lastly, the one we have not used yet, probability is a measure of how likely an event is to occur. And we've already talked about these. Probabilities can be expressed in what 3 ways? And that would be fractions, decimals, and percents. But really, normally we end up using decimals in math, but out there in the real world, usually percentages. People say, oh, there's a 10% probability. And we as mathematicians kind of groan about that, but we know what they're talking about and we don't correct, and it's fine, because in the real world percentages are used, but in mathematics we normally use decimals. But no matter what happens here, the probabilities have a value between 0 and 1, or if you're using percentages, 0 and 100%. So for probabilities, you are absolutely not going to go above 100%, like we were talking about with the abuse of percentages in a previous lesson. For the last little bit on this page, just when you think there couldn't be any more, there are 3 types of probability. There are empirical, theoretical, and subjective. Now, this one here, we can pretty much just call this an opinion. Empirical is real life, and theoretical all has to do with the math portion of things. So let's take a look at maybe some examples that'll get across the differences between these on the next slide. At a local high school, 150 students were randomly selected and polled to see who they would vote for in the next presidential election. And for those of you wondering, these notes were made in 2015, I think. So it was a while back when these were the candidates. So if they were able to vote, the results were as follows. So we have this: 52 people would vote for Hillary Clinton, 54 people would vote for Donald Trump, and then 44 people either would vote for someone else or not vote at all. Based on these results, what would the empirical probability be that Donald Trump is elected president? So we know already that there were 54 people that selected or would vote for Donald Trump. And as I said, we're trying to find the outcome we want. So that would be 54 people voting for Donald Trump. But then we have to divide that by all the total number of people that voted, which would be 150. And if you didn't remember this was up here and you added these up to 150, that's fine. But we would divide these and we would get a number that would be 0.36. Or if you like simplified fractions, you could use 9/25. Or if you like percentages, it would be 36%. But this is empirical. This is something that actually happened. High school students were asked. Somebody went out and had the patience to ask 150 high school students. So here they are. This is empirical. So moving on from that, we want to talk about the meaning of equally likely. And I sort of mentioned something like this in the previous page. Equally likely outcomes means all outcomes have the same probability. For example, if you were flipping a coin, let's say coin flip, heads or tails are your only option, and these are equally likely. It's 50% for heads and 50% for tails. So continuing with this idea of equally likely outcomes, if you assume the outcomes are equally likely, the probability of an event occurring is the number of ways E can occur divided by the total number of outcomes. And I've been saying this fraction for a very, very long time in this video already. So hopefully that doesn't trip you up too much. But we can use this to take a look at these next couple examples here for 13 and 14. We have a die that's being rolled, and for those of you that don't know, a die is just the singular version of dice. So a die is rolled, find the following probabilities. So you roll one die, boop, what's the probability of getting a 6? Well, there's a 6-sided die. For you D&D players out there, it's 6-sided die, so only one side has a 6 on it out of 6 possible outcomes. There we go. What is the probability that you get an even number? Well, it goes 1, 2, 3, 4, 5, 6 on the 6 different sides of the die. 3 of those numbers are even out of 6 possible outcomes. You must reduce fractions if they are there, so 1/2. Or in this case, if you like 0.5, either one of those work. Let's see, the probability a number is less than 5. So we cannot include 5 here. It has to be less than 5. So 1, 2, 3, and 4 all fit that bill, meaning we will have 4 outcomes out of the 6 possible outcomes, and that reduces to 2/3. Part D here, that's a special one. What is the probability you roll a 7? 0. There's no 7 on that die. It's impossible. For the last one, part E, find the probability you roll a positive number. Well, 1, 2, 3, 4, 5, and 6 are all positive numbers. So we will have 6 positive numbers out of 6 outcomes, and that will give us 1, a probability of 1, or 100%. For this next example, I want to make sure right away that you guys understand that these outcomes are not equally likely, because 1 has a probability of 1/2, 2 has a probability of 1/4, and 3 has a probability of 1/4. For these to be equally likely, all of these probabilities would have to be the same. All right, whoops, there's the bottom of the page. So one thing that you want to keep in mind is that anytime you add up all of the theoretical probabilities, which is what we were doing in 13 and 14 here, I didn't actually roll a die. I didn't actually spin this spinner here. So those were all theoretical. But when you add up all of the probabilities of a theoretical probability experiment, the sum is 1. It's always going to be 1. And even this, so this is something that students have trouble wrapping their head around. The probability that an event happens plus the probability it doesn't happen is also equal to 1. So let me run you through this little thought experiment. The percent of rain tomorrow is 60%. So what's the percent that it doesn't rain? I'm guessing most of you know rain would be 40%. And if you add those together, right, either it's going to happen or it's not. We only have two choices. 60 plus 40 is 100%, which is, as a decimal, 1. So that's always nice. And we're actually going to use this to our advantage here, both of these ideas to our advantage here on the next page.